Case of Earth. Shape a spherical mass 6 into 10 to the power 24 kg, radius 6400 km, density m by 4 by 3 pi r cube, 6 into 10 to the power 24. You can calculate. Now calculation of gravitational field and intensity due to Earth. This is the Earth of whose mass is m and radius is r. Outside the Earth, that is beyond the radius, we draw a Gaussian surface at a distance x. Now from Gauss's theorem, integration E vector dot dA vector equal to 4 pi g into m in or E into 4 pi r square, 4 pi x square or 4 pi r square equals to 4 pi g into m, hence E equal to 4 pi E equal to gm by r square or E proportional to, so E out proportional to 1 by r square. Now when r equals to the radius of Earth on the surface, E surface equal to g equal to gm by r square equal to constant, not f equals to m into mg. Potential, we have v equals to integration of infinity to r gm by x square dx, or v equals to minus gm by r. Inside, consider a Gaussian surface at a distance r, so integration E vector dot dA vector 4 pi g into m in into 4 pi r square into 4 pi g m by 4 by 3 pi r cube into 4 by 3 pi r cube. Thence mass of this enclosed body, this is the mass per unit volume, and this is the volume of this body, so volume into density gives the mass of this body. From this, E equal to gm by r cube, or E enclosed proportional to r inside the Earth. Now for potential, V equals to integration infinity to r gm by x square dx plus gm by r cube r to r x dx, or V equals to minus gm by 2 r cube under bracket 3 r square minus r square. Answer. Variation of G, that is gravitational field intensity. G is also called gravitational field intensity, or E, or acceleration due to gravity, with height. Here it is shown the situation. This is the radius of Earth, and from the surface the body is at a height s. Then we have F equal to gmm by r plus h square, or m into g dash, because it is equal to the force is equal to the mass into acceleration due to gravity. Acceleration due to gravity here is g dash. This is the mass of m, and g dash is equal to gm by r plus h whole square equals to gm by r square, taking r square common from this, so gm by r square into 1 plus h by r to the power minus 2, or gm by r square equals 1 minus 2h by r. This relation is true up to 5% change in the gravitational intensity or gravitational acceleration due to gravity. This implies g dash equal to g into 1 minus 2h by r. Also for change greater than 5%, g dash equal to g into 1 minus 2h by r plus 3h square by r square. Now this is the case, the intensity is changing, that is the acceleration due to gravity is changing due to the depth. Consider at a depth h a Gaussian surface of radius r minus h. Now integration E vector dot dA vector equal to 4 pi g into m in, or g dash. Here we have considered the acceleration due to gravity g dash, so g dash into 4 pi r minus s to the whole square equals to 4 pi g. Now m by 4 by 3 pi r cube into 4 by 3 pi r minus s to the cube, or g dash is equal to gm by r cube into r minus h equals to g dash because gm by r square equal to g, so g equal to r minus h, 1 r is here, r minus h, or g dash equal to g into 1 minus h by r. So inside the earth at a height h, the acceleration due to gravity or intensity of gravitational intensity will be given by this formula. Third, due to rotation of the earth or latitude, the situation is shown in the figure. A body is placed at angle lambda as shown here on the surface from the earth's center. Because earth is rotating, so there will be a centrifugal force in this direction, m omega square r. This is the r. Now from the gravitational force, sigma fr equals to mg minus ma square r cos alpha equal to mg dash, because its component in this direction will be m omega square r cos alpha and weight in this direction. So net force in this direction is mg minus m omega square r cos alpha equals to mass into acceleration m into g dash. So g dash equal to g minus omega square r cos square lambda. Because r equal to r cos lambda, if we take from this formula, then r will be, this is lambda, then r will be cos lambda, capital R cos lambda. Cos lambda equal to this length, this length by this. So this length will be r cos lambda. Okay. When g dash is equal to 0, g equals to omega square r cos square lambda equals to omega into under root g by r into 1 by cos lambda. Also tan theta equal to mg sin pi minus lambda divided by m omega square r plus mg cos pi minus lambda. What is calculated here? Second method, f net equal to here, this and this is the force, so net force in this direction, so we have written f net equal to under root mg square plus m omega square r का whole square plus 2 mg to m omega square r into cos pi minus lambda, because this is lambda, so this will be theta equals to will be pi minus lambda. Okay, or mg dash equal to m under root g square plus omega to the power 4 r square minus 2g omega square r cos lambda, neglecting omega to the power 4g dash equal to under root g square minus 2g omega square r cos square lambda. So g equals to under root 1 minus 2 omega square r square cos square lambda by g, or g into 1 minus 2 omega square r cos square lambda by g to the power 1 by 2, or g into 1 minus omega square r cos square lambda by g expansion by expansion. At equator lambda equals to 0, at equator lambda equal to 0, so dz is equal to g minus omega square omega square r, g dash equal to g minus omega square. At 4 lambda equal to 90 degrees, so g dash is equal to g. Due to the shape and size of the earth, the value of gravitational field intensity at poles remains greater than the value at equator. Calculation of shape energy of earth. Consider a elementary ring, elementary sphere of thickness dx at a distance x. Let us consider the x radius of earth has already been formed and dx thickness is to be formed. Now from potential energy du equals to gm dash by dm by r. Also m dash equal to mass of x radius of m by 4 by 3 pi r cube into 4 by 3 x cube into m x cube by r cube. dm elementary mass m by 4 by 3 pi r cube into 4 pi x square dx or 3m by r cube into x square dx. This implies du equals to minus gm x cube by r cube minus 3m x square dx by r cube. U in integration du minus gm by r60 to rx to the power 4 dx equals to minus gm square by r6 x to the power 50 to r. So U equals to minus 3 gm square by 5 r. This is the self energy of earth. Calculation of pressure stress inside the earth. We have dp equals to df by a or g m dash dm gmm by m dash or r square. This is the x square and 4 pi x square and x. Okay, side gm m dash dm by 4 pi x square into x square. This implies dp equal to g into m dash. Now m dash will be m dash equals to mx cube by r cube into 3m by r cube into x square dx by 4 pi x square into x square. And 0 to p dp equal to g into 3 m square by 4 pi r6 r to r from r to r x dx. Hence p equal to g 3 m square by 8 pi r to the power 6 equal to r square minus r square or g into 3 into 4 pi by 3 into r cube into rho whole square by 8 pi r to the power 6 into r square minus r square. Hence pressure is equal to g into 2 pi by 3 into rho square into r square minus r square. This is the pressure. Orbital velocity. It is the velocity of body or satellite with which it rotates in a particular orbit of Earth or any planet. Mathematically, we have gmm by r plus h sigma fn equal to m into an or gmm by r plus h square equal to m v naught square by r plus h ka m v naught square by r plus h. From this we get v naught equal to under root gm by r plus h. On the surface of earth h equals to 0, so v naught equal to under root gm by r, v naught equal to under gm by r square into r or under root gr or v naught equal to under root gr. For earth v naught is equal to 8.2 km per second. On the surface of two different planets, VO1 divided by VO2 is equal to under root m1 by m2 into r2 by r1. In terms of density, VO by V01 by V02 under root rho 1 by 4 by 3 pi R1Q divided by rho 2 into 4 by 3 pi R2Q into R2 by R1. So under root rho 1 by rho 2 into R1 by R2. Okay. So V01 by V02 R1 by R2 under root rho 1 by rho 2. If rho 1 equals to rho 2, that is density is same, then V01 by V2 equals to R1 by R2, that is V, orbital velocity proportional to the radius. Escape velocity VE. It is defined as minimum velocity required by any body through which, if it is projected, will not return to the gravitational field of the planet or Earth. Here it is shown the situation. Mathematically, we have from a certain height, from energy conservation 2 MeV square minus gmm by r plus h equals to 0 plus 0. This implies V naught equals to under root 2 gm by r plus h. Now for the surface of planet, h equals to 0, so V equals to under root 2 gm by r, or V equals to under root 2 gm by r square into r, or under V equals to under root 2 gr. For Earth, it is V equals to escape velocity 11.2 km per second. That is, if a body is projected with this velocity, the body will never return to the Earth's surface. For two different planets, VE1 by VE2 equals to under root M1 by M2 into R2 by R1. Or VE1 by V2 under root rho 1 by rho 2 into R1 by R2 in terms of density. Relation between the escape velocity and RMS velocity. If any gaseous molecule does not remain in any planet, then their RMS velocity remain greater than the equal to the escape velocity. That is, Vrms is greater than equal to V, and Vrms is given by under root 3 RT by M greater than equal to under root 2 G MP by RT, and T greater than equal to 2 by 3 under G MP by M by R into RT. This is the temperature should be greater than this value. This is the mass of molecular mass. So temperature should be greater than, then the body will escape. Okay. Then the gas will escape. Calculation time for the planet to stop revolving in an orbit. At any position x, minus g mm by r plus x equal to 1 by 2 mv square equals to minus g mm by r plus h plus 0, because revolving is 0 at this point. So v equals to under root 2 gm 1 by r plus x minus 1 by r plus h to the power 1 by 2. Also v equal to dx by dt under root 2 gm 1 under root 2 1 by r plus x minus 1 by r plus h, or this implies h to 0. Dx by under root 1 by r plus x minus 1 by r plus x under root 2 gm 0 to t dt. And from this we can calculate the time. Calculation of maximum height When the body is projected vertically upward from energy conservation 1 by 2 mv naught square minus g mm by r equals to minus g mm by r plus h, because its body goes to at r plus h. When the body is projected at angle alpha and reaches to height h, then minus g mm by r plus 1 by 2 m v naught square equals to minus g mm by r plus h plus 1 by 2 mv square. And for conservation of angular momentum, mv naught r sin alpha equals to mv into r plus h. And from this we can calculate the corresponding situation.